All right, now, there is one more equation on this first half of this unit. It is this.
Brought out the natural law.
All right, and that's why I said equilibrium is not totally done yet, but it's not going to be too difficult. Now, a couple of things to be said right here. The R is the gas constant, but it is not the 0.0821.
Oh, great.
It is the other value. I believe it is the 8.31.
Why would they put
Not
the
this
same
one.
variable for both? Come on now, listen.
It's because the units are different. The units are different, so that's why the numbers are different. So this gas constant, it's 8.314, yes. So 8.314 joules per mole K. Okay, it's given there. And this is the one that I would say, don't worry too much about memorizing it. Just make sure you know it is not the 0.0821.
Yes, it's in school. But when?
Today?
Yeah. Super session.
End of April usually?
Yeah.
Well, it has to be end of April because
Yeah,
you're.
but the exam is May 6th.
Yeah, the first one. Now the temperature, as usual, it's going to be in Kelvin, right? Kelvin scale, absolute temperature. Now, what I want to make sure is this quantity right here. Natural log of what is 0?
Oh, let's do the 8 number. 1? No, 0.
Natural log of 1 is 0. Now, so I want to take a moment to elaborate this. Now, if I remember correctly, the AP exam does not demand you to do this calculation. However, they need you to understand this from a conceptual view. So what does it mean? Well, it means this. If K is equal to 1, then it is at equilibrium. Perfectly equilibrium. It's going to be a spontaneous. There's no spontaneous or non-spontaneous reaction. Then, and that's where things got a little bit interesting. If K is bigger than 1, well, based on what we learned back in the equilibrium unit, that means we have more products than reactants, right? Or we say it is product favored, right? Well, if it's product favored, how do we translate this to spontaneity? Spontaneous, right? So therefore, if K is bigger than 1, then natural log of K would still be positive. Therefore, delta G is negative due to this negative sign right here. And then if we say, oh, what happens if K is less than 1? Well, we say it's reactant favored, right? Reactant favored. So it is not so spontaneous. So the delta G is positive. So that's where they tie their relationship together. So when we talked about all these weak acid and weak bases, like for them to break down, it is not quite spontaneous, or at least if I want to venture a guess, I'm going to say this. Why they change from spontaneous to thermodynamically unfavorable or unfavorable. For example, if you say weak acid, K is less than 1, right? Do they break down? They do. Is it happening? It is happening as we speak. So do we say it's not spontaneous? Then it would not make sense because it is happening. It is happening, so we should say spontaneous. So we should not look at it from the spontaneity point of view. We should just say, oh yeah, it's not that favorable to proceed with that direction. I'm going to guess that that is the reason behind the change of language.